Hello, Algebra 2 students. We're going to move on to section 3.6 and talk about the quadratic formula today and the different types of solutions and roots that you can get using that formula. So basically, mathematicians derived the quadratic formula from completing the square on the standard form of a quadratic equation. And so if you want to look at that process, it's on page 199 in your book. It's a little confusing, so I'm not going to go through it unless you really want me to, so let me know. But we're just going to start out with the formula and just see how it works and work a few problems. So we're on page 200. And this is lesson 3.6, the quadratic formula. We're going to talk about that today, and then in another video I'll talk about the discriminant. So page 200, we're going to talk about the quadratic formula. And some of you have seen this before and worked with it and things, and we've looked at it, but this is just more in depth with the formula here. So it's going to be x equals a negative b plus or minus the square root of b squared minus 4ac long fraction bar 2a. And that's the formula that you need to put to memory here. And you need to memorize because it's pretty important in mathematics. So this is it right here. X equals a negative b plus or minus b squared minus 4ac. So you're probably like, well, what do all those letters represent, and how do I work with this, and where do the numbers go? So that's what we're going to look at next. So we're going to look at example 1 in your book there and talk about when you have two rational solutions. So two rational solutions. Okay, so I'm just going to keep the formula up here so I can refer to it, and then we'll sub some numbers into it and things like that. So here's a simple equation. X squared minus 10x is equal to 11. So the first thing you have to do when you're working with quadratic equations is you're going to have to move your constant over, and you're going to have to set it equal to 0. So x squared minus 10x minus 11 is equal to 0. And so now we can figure out, this is our a value. There's that implied 1. This is going to be b, and this is going to be c. So it's all the coefficients of your variables there. Okay, so let's take our values and we're going to plug them in to that formula right there. So x is going to equal, well, it says the opposite of b. So the opposite of a negative 10 is going to be a positive 10. So x is going to equal 10 plus or minus the square root of, okay, b squared. So we have to add parentheses because it's a negative number, and we're going to square it. So minus 4 times 1 times a negative 11. Okay, and then long fraction bar 2 times 1. And so the next step in the process is to work out what's under the root here and then simplify this expression. So we get x equals 10 plus or minus, and we get 100, and then it comes plus 44 long fraction bar, and then a 2 here. And then we're gonna work that out. So it comes out to be the square root of 144. All over 2. Well, that comes out to be a 12. So let's go ahead and make more room over here so we can work the problem. Okay, so we get x equals 10 plus or minus 12 all over 2. And then you're going to actually go in and you're going to work that out. And so that's going to be x equals 10 plus 12 all over 2. This one is going to be x equals 10 minus 12 divided by 2. So this will be 22 over 2. And so x is 11. This will be a negative 2 over 2. And so x equals a negative 1. So you have negative 1 and 11. So remember, this is where it's going to cross the x-axis. These are your roots. That's what you just found. So it's just another process in finding the x-intercepts in a quadratic equation. So this is an example of where you get 2 rational roots. And next we're going to go on to when you get only 1 rational root. Okay, so we're at the top of page 201, and we're going to look at that problem. So this one says x squared plus 8x plus 16 is equal to 0. All right, so we're going to go ahead and identify. This is A here, this is B, and then this will be C here. Okay, so once I have those identified, I can now sub them in to the quadratic formula. So I'm just going to work it out. So x is going to equal, I'm going to have a long fraction bar. So the first part is the opposite of B. Well, the opposite of B is a negative 8 plus or minus the square root of B squared. So that's going to be 8 squared minus 4AC. A is 1, so we're going to put a 1 here. And then C is 16. All over long fraction bar 2 times 1. And then we're just going to simplify the problem, the rest of the problem here. X equals a negative 8 plus or minus the square root of 64 minus 64 all over 2. Well, this comes out to be 0. Well, the square root of 0 is 0, so 8 plus negative 8 plus anything is 0, plus 0 plus or minus 0 is still negative 8. So you're just left with a negative 8 over 2, because you don't really need to write this here. And so that's going to simplify down to a negative 4. X equals negative 4. Now, if you want to check yourself, you can always sub it in to your original equation and work it out. So let's do a little check. And you can do that with any of these problems. You can sub in whatever x value you get, and you should get 0 if you did it right. So we're going to sub in the negative 4. So again, we have to use parentheses and square this. And then plus 8 times a negative 4 plus 16, and that should equal 0. So negative 4 squared is 16 minus 32 plus 16 is going to give us 0. So 16 minus 32 is a negative 16 plus 16, which is 0. 0 equals 0, which is true, and so I did the problem correctly. So this is an example of where you have one solution. So let's move on to where you're going to have a complex solution. Okay, so, or actually it's an irrational solution. So we're on page 201, example 3 still. So this one has 2x squared plus 6x minus 7, and that's equal to 0. And so again, I'm just going to go ahead and identify my A value, the B value, and the C value. So once I have those, I can go ahead and sub them in. So x is going to equal the opposite of b, which is -6, plus or minus the square root of 6 squared minus 4 times 2 times a -7, long fraction bar, 2 times 2. So I just subbed everything in, and now I'm going to go ahead and simplify. Well, this comes out to be a -6 plus or minus the square root of 92 all over 4. And then sometimes they want us to estimate this, or they might want you to just leave it like this. So just make sure you read the directions, and then if you need to type it into your calculator, then type it in and round it to however many decimal places that they want here. So, all right, let's move on to the fourth example of what's going to happen if you get complex roots, or in other words, imaginary roots, where there's no x-intercept on your graph. So we're going to move on to page 202 and look at that example right there, complex roots. So this is where we're going to have no x-intercept. And your roots are going to be in this form, a plus or minus bi. And they're going to be complements of each other. So if you know one, you automatically will know the other one. So, okay, so let's look at x squared minus 6x equals a -10. So here we're going to have to move this 10 over. So we get x squared minus 6x plus 10 is equal to 0. So now I have it in the form where I can see my root, or my coefficients, and then I can plug it into the quadratic formula. So let's go ahead and identify those roots. So this is a 1 here, this is your -6, and then it's 10. So that's A, B, and C. And so now our next step is to plug it into the quadratic formula. So we're going to get the opposite of -6, which is 6, plus or minus the square root of -6 squared. You have to put in the parentheses here, minus 4ac, long fraction bar, 2 times 1. And then we're just going to work out the problem, do the math here. So x equals 6 plus or minus. So we have 36 minus 40 here, all over the 2. Okay, well 36 minus 40 is a -4, so we get x equals 6 plus or minus the square root of -4 all over 2. Well, we know that the square root of a -4 is a -2i, positive and -2i. So we're just going to simplify that down. And so we get x equals 6 plus or minus 2i, long fraction bar 2. And so now we have to just reduce all 3 of these. We're going to take 2 into 6 and 2 into 2. So we get x equals 3 plus or minus 2i. And that'll be your complex roots. So I hope you found this helpful, and I'll go ahead and make the next video about discriminants. See you later.